Hello guys, so today Leetcode day 4 challenge has arrived. So let's look into it. What's the Leetcode day 4 challenge? Okay, so it is design circular cube. Challenges design circular cube. Okay, so like it's a basic queue or data structure where we will have what I can infer from the question is there will be some designing question, like we have to design a queue data structure or something like that in class. Let's see. So this is queue data structure. There is a head, and we can also, yeah, there is an head, and we can also put a last in there, like previous, whatever. We can just simply use a head also. If the next of any current element, like we will use current we'll use a current node to traverse the whole string, and whenever we will have current dot next equal to head, then we will break it for a single traverse or whatever. It will depend on the question. So let's move to our question. Okay. Okay, so yeah, it feels like, yeah, so okay, let's see the question. So we have to design a circular cube, and here's the definition that, yeah, in Q we have FE4. Okay, so it is a circular queue. We have to, it's not like linked list directly. Okay, so we can also use array, like the first in, first out. FIFO principle. Okay. And the last position is connected back to the first position. It is also called ring buffer. Okay. One of the benefits of the circular queue is that we can make use of the spaces in front of the queue. In a normal queue, okay, it is not like simply circular linked list, it is some queue. Okay, we have to see that we cannot insert next element even if there is a space in the front of queue, but using the circular queue we can use the space to store new values. Okay, so implementation, the my circular queue. Okay, initializes the object. Okay, size will be given like k. We can initialize our circular queue class by this. Here the front, okay, it will return the front. If the list is empty, I mean queue is empty, return -1. Okay, rear means last element of the queue. Okay, so whichever was inserted first, it is on FIFO, first in first out. It is like a stack. Oh no, it is a queue, first out. So yeah, the stack is not FIFO, it is last in first out, LIFO. It is FIFO. So we have to implement a simple queue, but the thing is, see, if we will use an array, okay, if we will use an array, then the problem with is this: if we inserted 2 1, okay, at first we inserted 1, then we want to insert 2, then the queue will become like 1 and 2. Now we want to insert 3, the queue will become 1 2 and 3. Okay, now again if we want to insert anything, we can't, like, because we haven't taken a big array. So it's like in CPP or in simple we already defined the size of the array. But in case of queue, what we can do is, like, let's suppose we don't have queue. Okay, we want to insert 1. So instead of inserting 1, we will create a circular node queue 1, okay, whose next will point to itself. Now if we want to insert queue, then insert another element, like 1 is there, let's insert another element. So as it is in FIFO manner, we will insert it here, like we are inserting 2 here. Okay, so what we have to do with this is break this link, connect it to 2, and 2 will be connected to 1 again. Okay, and it's our head, it's always our head for now. Now let's take one more example. Like we have to insert 3 now, so 2 and 1 are there, 2 and not sorry 1 and 2 are there since FIFO now. So 1 and 2 are there. Now we have to insert 3. So we will break this bond now, insert an element whose value is 3, and then 3 will point to head. Okay. Now what if this head is gone? Like if we wanna pop this head, pop 1, pop head. Okay, pop head. So this head will be gone. 3, okay, before there is 3, now it is 2. So this 2 will point to 3. Yeah, it's the same as usual. But as 1 is gone, 3 will point to 2 and head will point to 2. So if there will be a pop operation, we will do head is equal to head dot next, head equals head dot next, head dot next. Okay, and pop this. Okay, we can do all this. Okay, let's go to the code. So front here in queue dq is empty is full. Yeah. So when will it be? Okay, no, the size is of k. So insert an element into the circle, return the true if the operation is successful. Okay, if the size will become more, like if your size is greater than k, then we don't have to insert it. So yeah, all done. Now let's, okay, so k is 1000, value is less than 1000, at most 3000 call will be made. Okay, so this is our, initially we have to, okay, I'm weak at this oops concept when it comes to, because I have done oops concept in Java. But let's see, it won't be that, it won't take that long. Okay, so if k is provided, then self dot set, I will define a variable size of the array, it will be k. Okay, and to enqueue or dequeue, okay, size will be k, max size. Max size can be k. Current size will be self dot size will be 0, because queue length will be 0. Self dot next will be none. Okay. No, we have to create a node first. So this is how it will be called. Create anything. Okay. So I have to create a node before this. Let's create a node at first. So we can take a node here. Class queue node self comma, we can input the value in the node and the next Okay, if there's nothing as next, then next will be none. Okay, we can't insert these all. Okay, yeah, we can insert. Let me check once. Okay, yeah, we can use this. Oh, I see. Okay, yeah, I was doing same, like, but I have taken it inside class. Oh, that was a great mistake. So class Q node is there, and here I will take. Here I will initialize self comma. Val. Okay. Self dot val equals val, and self dot next equals none for now. Let's keep it outside. Or okay, whatever. At first, let's define other things. We will go it at last. So in Q, if self dot current length is 0 is equal to 0, then okay. So I should also create one more thing, that self dot head equals none. Okay, this will be our head node for the circular queue. Okay, so if self dot q length is equal to 0, then create a node which will call head node, and self dot head equals to q node, okay, of value. Okay, value will be given, and self dot head dot next equals head. Yeah, it will point to itself. Okay, else and in case returning anything or not. So inside return true if the opposite. Okay. If can k be 0? Okay, will be always 1. So no big deal. And return true. Or if it is not the case, then I have to traverse the whole head, or instead I can keep track of last. Yeah, instead of traverse, we can keep track of last. Self dot last equals to none. So in the current scenario, our last is also the same. Self dot last is same as head. Okay. So what we have to do is self dot, okay, if it is not the case, and if qlen is less than max size, of course you have to take self dot max size and self dot qlen. If it is the case, then self dot head, Okay, not self dot head. Let's take a current node. Current is equal to q node of the value. Okay, and the next to the last. Oh, it is a queue now. So if it is a queue, we can't append it last. If we are in queuing, okay. If we are in queuing, we have to put this last as the current head node. Okay. So let's at first create the queue. Like self.last.next will be our queue node, like will be our current, and current.next will be our head, and head will become current. Okay, and return true, else return false. False or -1. 1 second. In queue, okay, return true. Okay. It should work. Like we are taking queue node value, okay, self.last.next current, and current.next will be our head, and head is equal to current, and last will remain last. Okay, let's try run it for our first case. So in here we have appended the current, okay, will be last to next, and head will become this. Move it, head will become this one. This is our head, and last is already this. Okay, so it's done. Now let's do the same for dec, like dq. Okay, so if we are at if cell dot qlim is equal to 0, return false. Okay, if else, what we have to do is to dequeue anything, we have to remove the last. Okay, if we will remove the last, the new last node will be the previous of that last node. Okay, so for that case we have to traverse the, yeah, we have to traverse it. So the problem is to dequeue any, like let's say, let's take one test case. Let us suppose this is our queue, circular queue. Okay, 1, 2, and 3. Now it is head and it is last. So to dequeue this, like we have to dequeue this, then the last will become this. Okay, the previous of last. So we have to travel till head dot next is not equal to last. Okay. We have to do that. There's no other chance to reach the previous of last. We have to reach here, and then we have to reach here and then break this bond and do this. All we have to do this is this, and make this as our last node. So we have to traverse in here. Okay, if self dot head dot next equals to is okay. So it is like if self dot qlen is equal to 1, then self dot head will become none, and self dot last also will become none, and size will be minus equal to 1, or like qlen. Self dot qlen will be minus equal to 1, and in here, okay, we have to use self dot head. So in queue we have to increase the size also. I haven't increased it yet. Okay. So as we have created in queued, let's increase the self dot qlen plus equal to 1. Okay, it's done. And same in here. Self dot qlen plus equal to 1. Okay. So it's done. Self dot qlen is minus equal to 1 after decoupling it. Now let's traverse it. Let current is equal to head. Okay. Self dot head while current dot next is not equal to head itself. Or instead of head we will say last. Okay, is not equal to self dot last, current equals to current dot next. Okay, and when we will reach that self dot next is equal to last. Okay, here also one more thing. Yeah, so if we found that self dot current dot next is last, then what we'll do is current dot next will become our new head. Okay, so last vanished out, and do we have to return it now? Yeah, we have to return. We must have to return it. Okay, no, yeah, only we have to do is to delete it. So yeah, it's bool, return true, and also decrease the size. Here also return true. So at front it is returned self dot head dot val. At rear return self dot last dot val. Okay, but what if okay, so if self dot, what we have to do is if qlen is greater than 0 is equal to 0, then return -1. The same we have to do it in here too. If qlen is equal to 0, then return -1. Now is empty if qlen is equal to 0, return true, else false will be returned automatically. Still we can write return false. Now it is full or not. So if Okay, wherever I have used qlen, I have to use self.qlen. Oh, that's bad habit. Self.qlen is equal to self. Max size. Let's update it. It will also work. No problem in there. Uh, Instead of using if, I can directly return it. Return. So if it will be true. Okay. Let's try to run it. It's too big to think of. We can simply. Okay, self is not defined. Okay, then we can leave it. We don't need it actually. Okay, so it is saying that Q node is not defined. Let's put it outside the class. Then, or rather, let's use self.qnode. Where is it saying? Okay, it is saying in self.head is equal to qnode at line 16 in Q. Yeah, first it will be in Q. Let's put self.qnode. If this line get error, then I will try to change it. Okay. It is saying head is not defined, but I have already put the self.head is equal to self.qnode of well. Let's print this head. Print head. I mean self.head. Okay. Let's see whether it is giving any output or not. Okay, so but here 3 is inserted now. Okay, no, and 1 will be inserted. Oh, sorry. Right side I have written self here. It should be self.head. My bad. Dot head. You will. I know. Only error I will found in this is I haven't used self dot and some. Okay, Q node is not defined. So everywhere wherever I used Q node in Q. Okay, I must have only used in Q. Of it will work fine. Let's see. Null, true, true. Okay, false is there. Why 3? Why 1 from my side? I have to print. Okay, yeah. 3, 3, 3, 3. So here I have to dequeue it or rear. Okay, I have to find the rear. Rear value should be 3 because I have already. So rear is 3. Okay. So it must be head dot val. what it is doing inside. Okay, current dot next is equal to self dot head, and self dot last equal to current. Yeah. Now the answer should be 1 comma 3. No, 1 comma 2. So it is not reading 3 because according to it, NQ, 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 3, 1 and 2. And answer should be 4 because okay, 3, 1, 2, then 3 is real. 3, 1, 2, 3, 4, 0. Okay. The input is 1, 2 and 3. 1, 2 and 3 and 4. Okay, 1, 2, 3 and 4. And the rear is 3. How could it be 3? The input is 1, 2, 3 and 4. If I include 1, then 2, then 3, then 4, how could rear be 3? Mm, 1 and 2 and 3 and 4, and then find the rear, then find is full, then 3 more operation, and at last find the rear. Okay. Okay, let's try run this sample test case. It is a bit confusing to me. Oh, the size is already 4. That's why. Okay. So we have to pop out this 4 and input. Okay, 1 is there, 2 is there, 3 is there. Now we push 4. We won't be able to push it. So 3 will be at last. But I am returning 1 in the rear. And rear means we have to return the last. 1 is there, then 2 is there. No, we have to return the head. So this is the problem. I am not returning head in here. Okay. And when it is telling about front, then it must be last. Okay, now let's see. Have I checked that? Okay, in front. Yeah, now it's working fine on this code. Let's run. Yeah, we don't have to run it. Let's submit it. Oh, it is accepted. So let's analyze what we did. We at first include our circular linked list. We try to check whether the queue length is 0. If queue length is 0, we have created a head and last node. Okay, and we put our head dot next is equal to head itself. Okay. Okay, let's just revise it once in 2 minutes. So if we have no node and we are creating this node, then this will be head. This will be head. This will be our head. We are creating one. This will be our last, and the link will be like this. Okay, head dot next equals to, like, head dot next equals to head itself. That's why I did this. Head dot next is equal to head itself, and increase the length, queue length. Okay, the same. And if it is for 0, or else to enqueue any element, we will do the same. We will enqueue it, and okay, see here. we have created a current node. For the last node, okay, after last node we appended or enqueued the current node which we have to enqueue, and we change the last node. So self, okay, then current.next is equal to self current.next will become self.head, and self.head will become current. Okay, so it will work fine. And for dequeue, just remove it. If the length is itself 0, we don't have to do anything, return 1 minus 1. If the length is 1, then head and last will both become none, because the only node inside the my circular queue will be dequeued. Or else go till the second or last and remove the last. And to remove the last, what we can do is simply, like, if we have to remove 3, it is at last, just break this bond, put this bond to this. Okay, it will also get broken, this will be result. Yeah, that's what I did. Now front rear is empty, is full is returned simply by using the last value, head value, or checking the queue length and maximum size. So okay, it's done. Thank you guys.